This is the second part of our normal distribution worked example. And what we're looking at here is the distribution of Arab horses. Okay. Now we calculated the first one, calculate the probability that an Arab horse weighs more than 940 pounds. We actually done two other similar examples. For example, where are they? Scroll down here, and there they are. So 940 pounds, we found it to be 221.1%, 21.19%. We've done two similar examples: 945 pounds, 18.41%, and 960 pounds, 11.51. So that was the first part with two extra questions. So the second part is calculate the probability that an Arab horse weighs between 880 pounds and 960 pounds. First off, what I'm going to do is, first off, we'll actually just talk about how we would tackle that problem. So I'll just go to the new page here. So the question would be written as this: probability of being between 880 and 960. That's how you would write it out mathematically. Okay, so this is what they call an interval. Okay, and we're actually more or less, what's the probability of being inside this interval? Okay, now this is the approach we'll take. That is equal to 1 minus the probability of being outside interval. Okay. And what does that mean, being outside the interval? Outside is either too high, or too low first off, or too high. Okay? So it is essentially, this is the probability of x being less than 880 plus the probability. So you add up the probability. So the probability, let's just actually go back here. Probability of being outside is equal to the probability of being too low plus the probability of being too high. Oops. There we go. So the probability of being too high. Okay. So the probability of being outside is equal to the probability of being too low plus the probability of being too high. Okay. Now, this is the probability of being too low is less than 880 kilograms, 880 pounds. The probability of being too high is probability of the mass of the Arab horses being greater than 960 kilos. Now, actually, just as a remark, if you have seen the last presentation, I actually answered this one already. The probability of being too high for that interval is 11.51%, 0.1151. Okay, so I've actually done that part already. Okay, so what I'm interested in now is the probability of being too low. So let's I'm just going to pause this for a second. So the probability of being too low, probability of x being less than 880. The first thing we do here is we calculate the z-score. Okay. And in that case, just if you recall, that is z0 equals x0. In that case, it's going to be 880 minus 900 over 50. Okay. So 880 minus 900 over 50, that is minus 0.4. Okay. So let's just take stock of where we are. Essentially what we're saying is the probability of x being less than 880 is equal to the probability of z being less than minus 0.4. Okay, so what we're going to do here is use the symmetry rule. Okay, and I'm just going to give a very quick version of the symmetry rule. So what we have is probability of z being less than or equal to minus 0.4. What we do is we change the direction of the relational operator. Okay, and so like that, it's a greater than now, and we change the sign of the z-score. Okay, so I think I might be just slightly out of shot there at the side, so I'll just move that in a bit. So what do we do there is we change the direction of the relational operator, okay, and also what we do is we change the sign. Okay, so here it is negative, and on this side it is positive. Okay, so here it is less than or equal to, here it is greater than or equal to. Greater than or equal to, yeah. Sorry, I just need one. Got a bit trigger happy there. Okay, so that's what we do. So this is what we're interested in now. Probability of x being less than 880 is equal to the probability of z being greater than 0.4. So what we go back do now is we go to the Murdoch-Barnes tables, and just like we've done in the previous question, we would calculate so what we're interested in, the probability of z, just to be clear now, we usually write it to 4 decimal places, 0.40, or 2 decimal places. So let's have a look at this here. So the column we're looking at is the 0.4 column, 0.4, and the row we're looking at is 0.4 row, and the column we are looking for is the 0.00 row column. So I sort of mixed up columns and rows there, just in terms of phrasing, but I think the picture draws the right conclusion. The answer is 0.3446. Okay, so that's the answer we were looking for. The probability of z being greater than 0.40 is 0.3446. Okay, so let's piece this all together now. So the probability of being too low is 0.3446. The probability of being too high is 0.1151. Okay, so the probability of being outside the interval is 0.4597, okay, allowing for some rounding error. Essentially what I did is just add those two there. So the probability of being inside the interval is 1 minus the probability of being outside the interval. Simple complement rule, and that is equal to 0.5403. Okay, so that's the answer, 0.5403. So let's just have a quick recap of the important things here. So the complement rule is the straightforward rule. What is the opposite probability? Okay, so it's one minus the other. Okay, the symmetry rule is the key one there. Okay, and essentially what you do there is, let's say we have some number minus, I'll just go for minus k here. Okay, so the probability of z being less than or equal to minus k is equal to the probability of z being greater than k. Okay, so what you do there again, change the direction of the relational operators and also the sign of so that's a plus there, that's a minus there. Okay, and finally the interval method, where that is a probability of being inside the interval is 1 minus the probability of being outside the interval, and the outside the interval is the combination of being too low and too high. So that's the worked example part 2 done, and we'll leave it there.